Welcome to another video. In today's video we are going to learn how to solve word break problem from the Leetcode. In this problem we will be given a string s and a dictionary of strings named word dict, and we need to return true if s can be segmented into a space separated sequence of one or more dictionary in words. What this means is we will be given a string s and we need to determine whether it is possible to break down the word into words which are present in the dictionary. If you consider this first example where the given word is Leetcode and the given list of words are Leet and code, we can break this word into two words Leet and code which are present in the dictionary. So in this case we are returning true. And let's consider this one more example. The given word is apple, pen, apple. Can we break this word into a couple of words which are present in the dictionary? It is possible because if we break the word here apple and that becomes one word, and the second word is pen and third word is apple. So apple and pen, both the words are present in the given dictionary. So in this case also we will return true. One thing to note here is that we can reuse the words which are present in the dictionary as many times as we want. Only thing is we should be able to break the given word into words which are present in the dictionary in the same order. So let's consider this one more example. Given word is cat, sand and OG, and here we can break this word here cat because cat is present in the dictionary, and then we are left with this string. And if we break it here sand is also present in the dictionary, but this OG, this string is not present. So if we try to break this word in another way, let's say we break it here cats, and cats is present in the dictionary, and then we are left with this word. We can break it here and because and is present, then once again we are left with OG. So in this case we return false because we cannot break the given word into words which are present in the given list. So this is the explanation for problem statement. Let's understand how we can write a recursive solution in order to solve this problem. Let's consider one example. The given string was apple, pen and apple, and given list of words were apple and pen. These were the two words which were present in the given list, and we should determine whether it is possible to break this word into words which are present in the dictionary. So what we are going to do is, initially we are going to start with our target string, that is apple, pen and apple. Then we are going to check all the words in the dictionary. So here in this case the given list consists only two words, were apple and pen, and we will check whether any of the word which is present in the dictionary starts with which is a prefix of the string that we are considering. Here in this case we are considering this string apple, pen, apple, and the word in the dictionary is apple. So this string starts with apple. So what we are going to do is we are going to remove that string and then we are going to continue the recursion. So now our string becomes pen apple after removing apple from the considered string. Here for this word, our string, considered string, does not start with pen, so we are going to stop here. And now we have this string, we are going to continue the same process. We are going to consider all the words which are present in the dictionary, apple and pen, and then we are going to check whether the current string starts with the word that we are considering from the dictionary. Pen apple does not start with apple, so we are not going to do anything here. Recursion will stop. But pen apple, the word that we are considering now, starts with pen. So we are going to remove that word from the considered string and then we are going to continue the recursion. Now we have apple. Now once again we are going to consider all the strings which are present in the list that is given to us, apple and pen. So here our considered string is apple and the word which we are considering from the dictionary is apple. So we are going to remove that part from the string which becomes an empty string. And here for this case, pen apple does not start with pen. So we are going to stop the recursion here. So while doing this process, if we end up with an empty string here in this case, that means we can break this word into words which are present in the dictionary. So this is the case in which we determine that okay, we can break down the given word into words which are present in the dictionary. So precisely if you want to consider the path that we took, in order to break that word is, first we removed apple from the string, and then the string become pen apple, and then we removed pen from the string, and then we removed apple. So these are the words that we can break down. So these three words here, those three words are, first is apple, and the second word is pen, and the third word is apple. So we can break down the given word into words which are present in the dictionary. We are going to implement the same solution, and let's see how to implement the same solution that we have discussed for this problem. The first thing is we are going to write a recursive solution, and whenever we write a recursive solution, we should be aware of what is the base case. In our problem, if a string is empty, if we reach an empty string state, that means we have broken the word into words which are present in the list, and then we are going to return true. So otherwise, we are going to consider all the words which are present in the list given to us. Int I equals to 0, I less than word dict dot size I plus plus. And here in this case, the first thing that we are going to check is if the string that we are considering, that is yes, whether yes starts with the dictionary word that we are considering, that is word dict of I. If this is true, then only we are going to continue the recursion. So here we are going to record the return value in a boolean. I am going to call it as word break success, and we are going to call this function recursively. For calling this function recursively, we have a string s, and we got to know that it starts with a dictionary word, that is word dict of I. Then we should remove that word from that considered word. So I'm going to pass s dot substring of, I'm just going to pass the index at which string starts, that will be word dict of I dot size. And one more argument that we have to pass is word dict. And what we are doing here is we got to know that our yes starts with the word dict of I. We are just removing that word dict of I from the yes, and we are going to pass it to further down the recursion. And if this returns true, if word break success, if this is the case, this will return true only if it reaches a empty string case, and in that scenario we have to return true. Otherwise we are going to continue checking other words from the dictionary, whether it starts with s, whether s starts with a word which are present in the dictionary, and in the end we are going to return false. Let's run this solution and check whether it passes the initial test cases or not. I ran into a network error. Let's run this solution and check whether it passes the initial test cases or not. Yes, this solution is passing the initial test cases. We have written a brute force recursive solution, and let's see whether it passes all the test cases or not. Yes, as expected, since it is a brute force recursive solution, we are getting a time limit error. So where do we do the repeated work here? So for a given word, we can call this word break repeatedly. So let's say we break down the word into certain word, and even after that, whatever the resultant string is, if we write the recursive diagram, we will get to know that for a given word we can call this word break repeatedly, even though answer will be same. So once you get a string and you pass it to word break function, whether it is true or false, that will remain the same. So we don't have to do that again and again, even if we get the same string in further down the recursion. So what we are going to do is we are going to store these answers in a map, and then we are going to do an early return. So I'm going to declare a map which maps from string to boolean, and I'm going to call this as word break status. And here in the recursion, first thing that I am going to check is whether word break status dictionary contains the word that we are searching. So if that is not equal to word break status dot end, if this is the case, this means the considered word status is already present in the dictionary. We are just going to return word break status of yes. Otherwise we are going to store the return value in our dictionary. So first thing that we are going to do here is word break status of yes will be equal to word break success. What this enables is whenever a recursive call is made, first it is going to check whether the return value is already present in the dictionary. If it is present in the dictionary, then we are going to return the status from here itself. Otherwise we will do the typical recursion. Let's submit this improvised solution where we memoized return values, and let's see whether it passes all the test cases or not. Yes, as you can see here, this solution is passing all the test cases. What we did was we just, instead of doing recursion for the string many times, we are going to store the result in a dictionary and we are going to do an early return. This is called memoization in dynamic programming. I hope you like this solution. If you are interested in learning more about other data structures and algorithm related problems, please check out other videos from my channel. Thanks for watching this video.